Hey, Matt Mathersum here with Matt Madness. Thank you so much for joining us and being a part of the program today. We really do truly appreciate it. And before I get started, I have to give a big shout out to my friends at Paws Saving Paws. You've heard me speak about these guys doing phenomenal work with rescuing dogs from transporting to adoption to fostering. If you are in a position to help these guys out, please reach out to them at Paws Saving Paws. You can even head over to my TikTok channel at That's My Dog to find out information there as well. All right, well, today we will be finding dy dx out of, well, let's see if I can figure out which way I'm going to stand. We've got x squared plus y squared equals 25. Let's find dy dx. Well, we're going to start with taking the derivatives of all of this, right? And let's do that right now with our operator d dx. And we've got our x squared plus our y squared. All right, and then our operator d dx over here for the 25. And let's just go ahead and deal with the right-hand side because we know that's going to be a constant. So there, that's taken care of. Let's take the derivatives here with respect to x. Let's go ahead and deal with our operator here again. And remember that this is just an operator. This isn't a fraction. d dx is not a fraction, no more than dy dx is our typical fraction. So let's just keep that in mind as well. All right. Well, I've got my d dx here, and I'm going to apply that with my x squared and my d dx with my y squared. All right, well, x squared and dx, well, those have the same base, don't they? So there's no real issue there. But we do have a situation over here with d dx and the y squared, don't we? Yeah, because y squared is telling us how much does y change with respect to x. Well, y can't tell us how much it changes with exception to y itself. So let's go ahead and deal with that situation right now. And we'll come back to the derivative of 2x because we know what that is. That's just 2x. We know that. No big deal there. All right, so our d dx here with our y squared, that's going to equal our d dy y squared dy dx. All right. Well, what's going on here now is I've got the bases the same. The base of the powers are the same. And I'm going to, obviously, we'll be using the chain rule because this is a situation that's a composite function. So we can utilize the chain rule. And let's go ahead and utilize the chain rule here. And this is just asking us how much does y squared change with respect to y? Well, that's easy for us, isn't it? It's just 2y. And we know that since y is a function of x, we're using the chain rule. So we have to apply our dy dx as well, don't we? Okay, well, we solved the debacle for the y squared. Let's go ahead and bring this up here, and I'm going to have the x squared situation resolved as well. And we know that's just 2x. The derivative of y squared is 2x. We've got our 2y here as well, and that's being multiplied by our operator, or what we're actually, the rate we're trying to find actually, dy dx, because that's really what we're after, right? We're trying to find the value of dy dx. All right, well, let's do that by eliminating the 2x on this side, subtracting it, and that'll free up my 2y over here. And we've got a negative now 2x, don't we? Because I brought this to the other side of the equal sign. Well, the dy dx is being multiplied by our 2y, so let's go ahead and divide both sides by 2y, and that will isolate the dy dx, won't it? Again, I've got a negative 2y over here. All right, I'm going to bring this down so we can see exactly what we're working with because I feel like that's a little bit cluttered. All right, we've got our dy dx isolated now, and we've got a negative 2x over 2y. All right, we're still isolated for dy dx. We've got it isolated, but we can cancel out the 2's here and giving us dy dx is equal to, negative x and y. All right. Well, that is how we find dy dx out of x squared plus y squared with a radius of 5 once we square the 25. That's all the time we have for here on Math Madness. I'm your host, Matt Mathersum. I'm going to see you guys really soon.